Thank you very much for staying for the last session of the day. I hope that I can make this time worthwhile for you. My name is Guy Ernest. I'm working as part of the Amazon AI team, and my job is, my mission in life now is to try to get as many people to use deep learning, no matter where, how, and I hope I can try to show you why and what is deep learning, what is artificial intelligence, what is machine learning, and how it's relevant for research, for almost everything that we do in our life. So what we want to talk today is about, again, some definition about artificial intelligence. We'll see how people are using the cloud today to do research. Again, when I say today, this is a thing that we have for the last 10 years or so. I will start to show where we are going, what is Amazon AI, how it's relevant for research, universities, and many aspects of our life. I will do a focus on deep learning, and at the end, I will try to show you how you can get started. Hopefully, it will make you interested and try to do it yourself. So we talked about machine learning, deep learning, artificial intelligence. They are interchangeable, overlapping in some ways. This is one definition, a system or a service which can perform a task that usually require human intelligence. And here I want to start with a story. In 2012, the annual competition of image recognition was held. And until this year, the world record in one of the, think of it like the Olympics, was 26%. 26% is what is the misclassification of labels. And for many, many years, this world record was slowly being improved, but from 27 to 26.5 and so on. And then in 2012, there was one competition, one team that broke the record, and it was something like 15. So thinking like the Olympics, and you have 200 meters, and the world record is 26 seconds, and then somebody is coming and breaking and running it in 15 seconds. This is relatively what happened there. And this was the first time that people actually used in a massive scale deep learning. And again, trying to give the ability of humans to the machines, because until that day, the machines were way beyond people. The world record, again, when humans are trying to do this task, they're usually around 5% misclassification. Some of those images are hard to detect. So again, I said it was 26. We managed to get it to 15. Today, the world record is even less than 5%. It's around 2.5%. So today, machines are better than human in what we call artificial intelligence, or the ability of people to do stuff. So today, machines are doing that even better than us. And I will show you some other example around that. So again, I wanted to start with this definition because it gives us where we want to be. We want to be in a point where we can take our abilities and even make them better. So I hope that you saw these couple of slides in the keynotes. Matt Wood presented why do we need scale. And machine learning, and especially artificial intelligence, is all about scale. The more data you put, the better the model. So the problem is, how are you able to take as much data as possible? How do you get data? And then how do you train on this data? And how do you use these models, and how you predict using those models? Because predicting in the cloud is not always the thing that you want to do, latency and things like that. So the problem is, how can you get as much data as needed? Think about millions. Again, for this image recognition competition, we are talking about hundreds of millions of images. Alexa is trained on, again, hundreds of millions of speech files. How do you take them, train them, and use them so you can actually do this kind of a magical moments with artificial intelligence? So data is hard, but with the cloud it's much easier. Again, you can have petabyte, exabyte of data. we are talking a lot about this kind of snowmobile. Yes, the snowmobile that we showed in reInvent, how you can basically drive a truck to your data centers and get all this data that is just lying there and moving it to the cloud. So now you can start innovate and build incredible machine learning and AI systems. And of course, there is a lot of data being generated today directly to the cloud. We're talking about Internet of Things and things like that. Again, this AWS IoT is another very big driver for getting data. Training is very important. And talking about GPUs, I build the deep learning models, and I will show you at the end some examples of that. I built this kind of a model about 25 years ago. So all those technologies are not new. They are known. We thought about it way before, but it was very, very hard. It took me something like 2 years. It cost me about $1 million. And what I managed to build was something that couldn't actually understand text. Again, it was something that tried to read handwritten text. It can identify the important words in this text. So if somebody wrote the word bomb, I could find it, but I couldn't understand the overall text. Again, this was 25 years ago. Today, with those GPUs and the cloud and things like that, I can do something way better in a couple of minutes, a few dollars, and the quality will be much, much better. And the last thing I want to highlight is that it's not enough to do machine learning or AI in the lab. So it's great that you build something, it's working here in the lab, but it doesn't help me, again, the user, to enjoy that. So we need to take the AI or the machine learning from, let's call it the cold, the dark data centers or the labs to the warm place where people live. Again, we want them to touch people. We want them to be in their home, in their hats, in their mobile phone, whatever. So it's very important to be able to take and deploy those models from the cloud to people, to where people are. And this is what we are talking about with what this kind of at the edge. So it took us about 10 years to convince you guys that the cloud is the best place for storage, for compute. Everything should move to the cloud, right? Migration to the cloud. The next 10 years, we need to find a balance. What is going to be in the cloud, namely, training of deep learning and a lot of data to store there. But what do you do on the edge, or can balance between what is in the cloud and what is on the edge, which will be basically inference or prediction of deep learning models. Again, think about all those robots that we're going to have and things like that. So this is the balance that we need to do, and we are starting to go to this way. And you probably heard about green grass, and if you think about what we're going to innovate in the next 10 years, you will see many, many things into this direction. So we believe that AWS is the place for artificial intelligence, and I want to show you a couple of examples. So we mentioned data. So if you don't have data, then you cannot build anything. So we have in S3 a lot of data, some open data. This is one example. This is coming from Amazon, our mothership. We want to be able to identify those items so we can pick them easier. We were going to talk about some logistic problems we want to solve. So we open up a lot of data. I don't remember the number itself, how many millions of images we have there. But now everybody, including universities research, can take those images and train them because they are already tagged. So we tell you what we have in those images, and you can train models and build on that. And about 2006, Netflix opened up the first big data set for recommendation engine. It was a big revolution because until then, most of the researchers had very, very little data to work on. So it's great to do this iris classification and some other data sets. But if you have gigabytes and hundreds of gigabytes of data, it makes everything way more interesting and much more harder. But the science actually starts when you are talking on this kind of high scale. So we have data sets in different areas, this geospatial and environmental. So all those satellite images, they are used for many, many things. So we have one company that are looking on those images and trying to count how many cars are parked in Walmart. And by that, they can predict the revenue of Walmart in the next quarter, so they know if to invest or not in the company. So we have those hedge funds doing that, but it's also being used to actually analyze a country. So we have people looking on exactly those images of a country and identified how this country is behaving, again, economical, forest, fields yield, and things like that. So you can actually optimize what's going on in a company, in a country, the policy that you are doing, the project that you are trying to initiate, evaluate how impactful they are just by analyzing this kind of images. So there are many, many use cases for that on all aspects of economics, politics, and things like that. Genomics is a lot of interest. We have quite a few data sets around there for machine learning, the common crawl, and some sensor data. So there is quite a lot of data, and we want more. So if you have some data sets that you want the world to try to analyze, then bring it on. We'll put it in S3. We'll share it on our expense with researchers, and we'll give, again, more research opportunities for universities and other innovations. The other important thing I want to highlight is that we want to support this kind of research. Again, we are supporting and we are serving businesses. We don't want to take money from people who are actually providing knowledge to the universe, to this kind of open source research publication and stuff like that. So we are giving a lot of credit both for people who are building research infrastructure or just doing research in your faculties. So you can use those grants. Basically, it's some free AWS credits, which could be a lot of money. This is one example that I want to highlight from this genomic. Again, genomic is one of the places where we have a lot of innovation. So we have this company, DNS Nexus, and the company that used them is Baylor. And they did a very big project on trying to analyze thousands. Again, you can see the numbers, 24 terabytes of sequencer content every month. Overall, it was more than 1 petabyte of data. But it's a huge effort. Usually, it can take years to do such a thing. They managed to finish that within 10 days. And you can see that in peak, they use tens of thousands of cores to do that. And if they don't use that, again, it's elasticity, you can return it and so on. So you can scale up, scale down as much as needed. It's one example of a very big research in this area, and we have quite a few others in the same concept of a lot of data. The data is in S3 or in Glacier. It can be pulled up to a cluster, and this cluster can be used for a limited period of time, but do a lot because it can scale dramatically. And one thing that sometimes I find people missing is that we are coming from the mothership. Remember this Amazon example I mentioned? So we understand selection. We understand that there is no one tool that can do everything for us. And we want to highlight that if you need to do some kind of a research, which is using what we call this cluster HPC, very tightly connected, the network must be optimized for that. So this is something that you can do on AWS. If you do want to use something which is more like this grid, loosely coupled, inversely parallel, and things like that, you can use that. And there are two different environments. One will use what we call the placement groups, where the network is optimized, and the other one will use something like the spot instances, which, the machine can go down, but the price that you overall pay for this machine is almost 90% the on-demand price. So it's very important to understand what is the use case that you want to do and find the right balance of services. It might be confusing because there is no one tool. Again, there's no one Oracle. Everything is in the Oracle, and we know what it is. It is broken down to different services, but overall you have the flexibility to do one or the other, or maybe even a combination of both. So we're talking about research and innovation, and we want to explain that we see different types of innovation. Some of them are very small, again, just new features, and I will show you a couple of examples for that. Others are completely new experience, or something which is what we call this breakthrough advances. And research can be small, it can be big, and it can be long-term, like sending rover to Mars and things like that. It's still important to start usually with small things to get confidence that machine learning is the tool to use, and we'll talk about the movement from thinking about building software to thinking about machine learning models. And we see those companies, and I want to highlight a couple of them. So we have NASA, of course, what I mentioned about the rover and the streaming that we did in the previous session, if you've been in this room. We have an interesting competition going on. You see Carnegie Mellon and University of Washington. So they are going head-to-head in a competition which we call the Alexa Prize. So each one of those universities and a few others are building a chatbot which is able to chat. So if you go to your Alexa, if you have an Alexa, and you ask it, let's chat, it will open up a discussion with one of those chatbots. And at the end of the discussion, you can rate. And you say if this conversation was good, 1, 2, up to 5 points. And we are doing the competition among those companies, and we are really going head-to-head. 1 week, University of Washington, I think now they are ahead, and then the week after, Carnegie Mellon are improving because they get the feedback and they can improve their chatbot. So it's a nice competition. Hopefully, it will get to a point that the AI will be able to chat with us, and this is what we want to do. But also some serious, again, this is of course serious chatbots, but more in this kind of medical framework, what we have with Stanford. So probably you saw these slides before, but medical imaging and this kind of healthcare in general is going to change. It's going to change dramatically in the coming years. I was in India a few months back, and I met some people from the government, and what they told me is that one of the biggest problems of India is that 70% of the doctors there are not actually doctors. They are the doctor of the village, they are treating people, but they didn't finish, they didn't graduate from a medical school. Why? Because again, India is very, very big, not every village can get a real doctor. So what can we do to help Africa, India, or even trying to identify those diabetic patients earlier? And this is where AI will be able to help us, because it will give us the augmentation, the ability of regular people like those doctors in India to be able to diagnose a patient early and accurately, and of course in a consistent way. We're talking a lot about security, in the context of enterprise and encryption and things like that, but it's not only relevant for trying to stop hackers. This is one of the bases for being able to get FDA approval, HIPAA compliance, and all those private user information, that it's so important to make this kind of, give me a lot of data, but this data is private. Okay, but this data is anonymized, it's encrypted, and so on. So having those security levels that we have, those KMS and others, are not just to against hackers, but also to allow us to build this kind of innovation. Those are examples that you saw before. If you want to optimize this kind of a team play, what do? You need to have scouts that will go and monitor the movement and measure the distance and the speed of the betting and so on. Not anymore. Today, it's enough to analyze the video of the game. And this is a company called Huddle. This is what they are doing. They are taking those images, and this is what I mentioned about being better than people. Because now, from this video, I can analyze and score each of the players, and I tell him how much he's behaving according to the tactics of the coach and things like that. So it's really something that allows us to scale our human abilities to levels which we cannot get by just putting people on top of that. This is another common example of self-driving car. And also I want to highlight that the self-driving cars, the ability to identify where is the car, where do we have people, how the road is behaving, is something that we can improve. Because if you look on the image on the right, it's hard. It's hard to do it at night. And usually the way I try to explain that is that machines don't blink. So we, as humans, sometimes we are tired, sometimes we are blinking. The machine don't do that. There is also downside because they don't come up with this kind of blink ideas. But overall, they are very consistent in their ability to, again, drive in the dark. Or to be able to identify this we call the pixel level object segmentation. What is a car? What is a person? Where is the road? Where are the obstacles in it? And this is another important ability of those machines, is that they can look on different spectrums. So they don't need to only look on the visible vision. They can also look on different spectrums. And what we do in this area, you can see that we're trying to identify where are the cars. We can use the actual image, but we can also look on some infrared or some other sensor. Inside of Amazon, we are trying to do something which is called Amazon Fresh. We want to sell you fresh items, for example, strawberries. But strawberries, you know that they are very sensitive. If the strawberries are crashed or rotten, you're not going to be happy if we're going to send those strawberries to you. So we need to try to identify what are the good strawberries and which one are the low-quality ones. How do we do that? We put people. People will look on that, but this doesn't scale. So what can we do? We are putting this kind of images. Those images are not taking this kind of one image, but 19 different spectrums of the same image and trying to take this information to identify what are the best strawberries and which are the worst one. And again, the same idea is something that we as people will not be able to look on those different 19 spectrum, and the machines can do that. This is why their prediction and their classification will probably be better than what we can get with experts. We saw those examples of Wolfram. This is what is being used by Siri. When Siri is being asked a question they don't know, they will fall back to Wolfram, and you can see that it is using deep learning in the background, again, specifically MXNet, which I want to highlight. Let's quickly shuffle through those examples. I mentioned Netflix. Again, Netflix was the one that started in 2006 with this Netflix prize, when they gave $1 million to the team that will improve their recommendation engine the most. Again, $1 million, it's a lot of money for a research institute. And they open up all their data. Not all the data, but a very big chunk of the data. And they are innovating a lot since then. This example I want to put here because they had a big problem. They want to expand globally to 120 or so, 140 different countries. And to do recommendation on different content for different people in different languages, it's a very hard problem if you try to do it just by putting machine learning expert to try to optimize that. And this is where deep learning can go and help, because again, deep learning can actually learn the language while it's actually observing the data. So it's much faster to do this kind of scaling up of training of those machine learning models if you use deep learning. And this is a proof that they could do that very, very efficiently just because they have so much data. Again, data is a very critical aspect of training those models. I want to talk about Amazon for a second, because I think it's an interesting discussion where the world is going in this direction. Because I think that Amazon is quite innovative in this area. And one thing that we are doing today, we are moving from a company, which is a technical company. We are not calling ourselves anymore SDEs, software developer engineers. We are trying to become an MLE, that is machine learning engineers. So I don't know what is going to happen to universities, what kind of training you need to change in your curriculum for those graduates, but this kind of a shift from developing software to building models is something that a company in our size has decided to do just because you can see so many things that can be achievable if you have these techniques in hand. And what we believe is that many of our customers and many of the other organizations will do a similar shift. Not just hire developers, but hire people who are able, you don't have to have a PhD, but you do need to be able to engineer a machine learning model. So what do we do at the fulfillment and the logistic? I don't know if any one of you visited the fulfillment center, and we do allow those visits, so I encourage you to come there. Those magical moments that AI can give us is something that you will see there. So you can go there and see those robots driving around. You will wait for them to collide. They will not going to collide. As I mentioned, they don't blink. And they will just dance around and bring those pods to the pickers. The Primaire is another good example that you will see drones flying around bringing those items to you. Such a discovery is another good example. Let me quickly jump to the console and show you what I mean by new experience and new products and a new way of using services. So this is the Amazon page. You know that most people are coming here, searching for the item, put it in the shopping cart, and they leave. But if you go to a different store, let's say you go to Costco, you want only to buy milk and bread, and then $500 later, you have a cart full with so many things that you just didn't know that you wanted and you needed, but again, you bought it. Can we give you the same experience? And maybe we can. So if you want to go to, again, to Amazon and see this banner, maybe you saw it already, not many people clicked on that. But this is an experiment that we are trying. Let me click on that for you. So you can see the title is New and Interesting Finds on Amazon. And you will see that the experience is going to be completely different than what you see in our website. You can see that you have items, what we call beautiful items, interesting items. You can click on each one of them and find some other relevant items which are similar to it. You can see that here on the top, there are categories, for example, photos. And you can see those photos, so relevant items which are in photo category. How do we do that? We don't put editors to do that because our catalog is so big, it's changing all the time. We have to put, again, machine learning and try to identify what is beautiful, what are the things that you will find interesting, what is relevant, and so on. And also the categorization. All of those new discovery experience in Amazon is something which is, again, built on AI. We can improve existing products. Again, if somebody has a Kindle, you probably are familiar with this X-ray functionality. So if you are not familiar with Game of Thrones, with Khal Drogo or some other people are coming in and disappearing, and then they're coming back and so on, you can basically track them using this X-ray technology. Which is, again, analyzing the text and highlighting for you where we are, and you can find and navigate yourself in the story. As I mentioned before, it can work on almost any language. And this is what's so powerful about these technologies, because it doesn't really require a language model. You just need to be able to access a lot of data and create the same experience here in this example in Japanese. It can also work on video. It doesn't have to work on text. This is an example of the same experience, the same X-ray, now applied to video. So you see, it's a hard scene because people are on their back to us. Still, we can identify who are the people. Again, the name of the actor, the name of the character, what kind of music is being played, and so on. And we also try to build new stuff, completely things that we didn't think that are relevant or possible in the past. The Echo devices and the Alexa service, and I don't know if you know, but there are quite a few other form factors to it. This is the Look, so it also has a camera and a depth camera, so we can actually measure you and give you advice about what to wear and the size of your clothes. this is another example. This is the, what is the name of that? It's not the look. This is, to remember. But again, another Alexa form factor that you can watch or not watch. I remember what it is. And you might know that we are basically an an online store, e-commerce, but we are starting to go into physical stores, and we are trying to do many, many things to see what makes sense in this area. And what we want to do something which is way better than a physical store. So try to monitor where people are walking, what are they taking, and give you this kind of a magical experience. Go inside, pick any item, don't stand in line, just go out, eat your lunch. And it's using a lot of deep learning and AI in this sense. So I think that it's important to remember that technology is here. So it's not, I don't want to brag, Amazon is great, we're doing a lot of stuff. We want to get to a point where the same thing that we have internally, everybody can use. And this is what we did with AWS. And this is the mission of Amazon AI. So again, this is the quote from the shareholder letter from Jeff Bezos. And this year, he decided to highlight artificial intelligence because he believes that this is the next big thing that we as AWS can offer. So we democratize compute, we democratize databases, storage, and so on. Now, our job is to democratize AI. So we want to get to a point where it's so easy for you to do whatever Amazon is doing. Everybody should be able to do that. And for that, we have those different layers, and I will try to explain some of them. So the top layer is what we call the simple API. You don't need to be a data scientist, and you can already do some AI. Recognition is image recognition. Again, give me an image, I will give you labels. Give me an image, I will tell you demographic information about this person. Male, female, age, smiling, and so on. Give me 2 images, and I will tell you it's the same person. So is it relevant to again, doing research and using that, not in the context of Amazon Go or in the context of security and things like that? So I think it's great because you can actually analyze people. Think of it like I had a discussion today with somebody who wants to understand if people are wasting food. So he wants to count how much people are buying and taking to their plates and so on. So again, using put a camera, and you every second take a frame and count how many people are there in each line or each one of the stores, how much they're taking into the plates and so on. This is something which is very easy to do. You don't need to go and train models. Just put a camera and you create this kind of video analytics and crowd analytics on every place. Is it going to be a restaurant, a street that you want to monitor, a demonstration that you want to analyze the reaction of the people? Again, whatever the thing that you want to research, again, if it's people, then you can use this kind of technology to understand what you see from this camera. Or you can track where people are going around and understand the patterns of behavior. And again, you can find it even in the crowd. So it's an example. You can put an image with, again, many, many people in this image, still to find the specific person. Or you can use that, this is C-SPAN, trying to analyze what's going on in the Congress. So every discussion in the Congress, every speech is being recorded with this C-SPAN, and now it's also being analyzed. So we know who are the people, where they are, and if you want to find the speech 2 months ago of a person, you can do it immediately. Poll is another interesting example. So this is how it sounds. Probably doesn't.
And of having nothing to do. Once or twice she had peeped into the book her sister was reading, but it had no pictures or conversation.
Okay, so I don't want to show too much of the text-to-speech. It sounds lifelike, but I want to take you to a different place. And this is Troy. He's a solution architect in Amazon. He's wearing the Amazon shirt. And he has a son. His son is 16 years old, and he has autism. And so it's, again, it's not an easy situation to live with. His son doesn't talk, they don't have any conversation, things like that. But he's worried. He's worried that now he's becoming old enough to start living on his own, and how can I help him? And the minute he saw Polly, he immediately came up with the idea that now he has a way to structure the life of his son and give him his schedule and remind him to brush his teeth and to remind him to go to sleep and remind him to go down to eat and all these kind of things without him need to be there. And this is exactly what he did. He took, and again, this is his son. You can see his reaction to some plays that he's doing with lights and with voice and things like that, as he's reacting to that. And he believes that, again, this is a great way for his son and maybe some other people with similar issues to get a surrounding environment that they can be still controlled, and I won't say cured or live normally, but they can live much easier life, and again, it improved the quality of his son's life dramatically. Lex is another, again, this is the last of the services that we have on this Amazon AI top level today. And I want to highlight something here which is important, again, for research purposes. So it's a place to, a way to build a chatbot in voice or in text. So you can basically order book a flight and things like that. But the thing that you can get out of that is basically to analyze and understand the way that people are interacting with you. Whatever is the service that you're providing, is it flight tickets or providing a health service? And if you remember the slide that I showed in the beginning of the many companies that are using us, you could see Ohio Health and the American Heart Association. All these companies, this is what they want to understand. Analyze me and give me the interaction of patients, of people with my service. And this is a great way to capture that, and of course also to respond to it. But the ability to analyze whatever is the channel you are discussing, to do whatever is the system that you want to integrate with, but now you have a way to understand what people are actually asking you, is a very powerful concept of not just improving lives, but also improving the services that you offer. Now, this is some example you can do here, and we're going to give quite a few other of these services later this year, and again, stay tuned. We did talk about clusters and EMR and HPC and things like that, so we do see people doing what we call this AI platform, so build your own models. But I want to jump to the deep learning because, again, as I mentioned, this is one thing which is new. It's very, very powerful. And those AI engines, so I mentioned before the selection. So we are talking a lot about MXNet, and we are running workshops about Apache MXNet. This is the first agent that you see there. But we are a retailer. We want you to choose the tools that you want, and this is why it's so important. So if you want to have something high level, use that. If you need the EMR or Spark ML or Python and R, use the mid-tier. But if you want to use any of these deep learning libraries, we also want to make it easy for you to do that. And we don't know which one will be better, and certainly we don't know what will be better to your specific use case. So again, we want you to be able to build this end-to-end training in the cloud. We're going to give you this Volta GPU. This is the state-of-the-art from NVIDIA. We did a lot of optimization with that. So I think we have some numbers here. Yes, you can see here that we optimized MXNet specifically, but probably some other libraries will do the same, to take the K80, this is the P2 that we have today, the GPU that you can run in the cloud today, and optimize it from something like 34, 35 hours to less than 6 hours. Again, it's a huge boost in performance and, of course, in cost. As I mentioned, MXNet is already optimized, but any other language library will probably do the same. We will give it later this year. The inference in the cloud, but I want to jump to the inference in the edge. I mentioned this is the new thing that you're going to see in the next decade, a lot of things like that. So I'll quickly jump to this example. And what you see here is it's a bit stocky and creepy, but the concept is very powerful. You are training a model the model is being trained in the cloud. Again, there you have the data, there you have the GPU, the compute, and so on. But the deployment can be to this drone, and this drone is completely disconnected. It's running autonomously, and of course it's being driven by a person, but the tracking of the person is something that the model is doing on a very low-cost GPU in this sense. Another interesting example is something which we call the amalgamation, and hopefully you can hear that. Again, so I don't know if you could hear it at the end, but the same concept. You build a model in the cloud, you deploy it in this kind of amalgamation to the mobile device. The mobile device is not connected to anything in the cloud. It's just doing the inference, the prediction locally on the device, and this is the blind tool. So now blind people can walk around and see without, again, even if there is no network. Of course, it makes sense that you can do the same with the self-driving cars and stuff like that. You don't want the car not to stop because there is some latency to the cloud. And you can do it even in the browser. So the idea is that you can actually deploy a machine learning model to the browser, and you can do some decisions there. This is an example of image recognition, but you can do security checks and stuff like that. Not everything should be going back to the cloud. So let me quickly go back to, again, to this slide, which try to explain what is deep learning and how deep learning is actually working, and what is the thing that we as people should be focusing ourselves. So instead of trying to write code, we should try to build those models. So what is a deep learning model? These are what you see here on the top. Let's see if I can highlight that. Okay. So this is a network. Which has different layers. The reason why it's called deep learning is because you have a deep layer of again, those symbols. Each one of the symbols is doing something slightly different. And what we need to learn, and this is what we're usually doing in our deep learning sessions, is to explain what is a fully connected, what is a convolution, what is a recurrent network, and so on. The symbol set is not that big. It's probably 20, 30 or so those symbols, so there's not too much to learn. The combination is tricky because it's not obvious how to connect them together, but whenever you do it right, the magic is like that. So you can take any type of input, and this is what we saw before. The input can be images and videos or speech and again events and then text and things like that. You do this kind of feed forward, you are running it through the network, and then you have any type of output that you want. We saw the segmentation with the cars, count faces, even create art, do caption, labels, and so on. And the idea is that if the network doesn't understand what you ask it to do, so you gave it the input and the output was wrong, you will just punish it, and this is what we call the fit. So you will go and train the model. This is why you need a lot of data until it does what it needed. So this is exactly the type of training and magic that we can create if you have, again, a lot of data and you know what kind of output you want to generate. And in this sense, this is not the master algorithm yet, but it really can be something which we don't even think about it. So I gave you an example of text as input. So can we give text as input and generate image as output? Usually we take image and we give labels, but can we do the other way around? So the answer is yes. There are techniques that I can take this kind of a label. Let's say I want to add a mustache to a face. So you will just say, add a mustache, and then on the other side there will be a face which now the mustache, now it has a mustache, in a way that you will not be able to see that. So just like you did the Photoshop pixel by pixel, the machine will do it for you, again, or generating some other types of images. So it's really the promise, again, it's not going to be easy, but the promise is to take almost any type of input and generate any type of output that you actually need. And again, the example that you see here is how do you do it with the MXNet. You see MX model and feed forward, or the fit that you see here, or these are the different symbols that we are providing as part of the library. But again, as I mentioned, there are other libraries out there if you prefer to use Keras and TensorFlow and some others. We want to make it easy for you. How do we want to do that? Again, we saw those examples. Let's quickly jump over that. So how do you get started? We want it to be easy for you. So we provided this example. Let me jump in and do this kind of a quick demo how to launch it. So again, the quick demo, you're going to EC2, because this is where your compute is going to run. We're going to choose an instance. I will go to the marketplace. In the marketplace, I have quite a few offerings. One of them, or two of them, are from AWS. You see we have an Ubuntu version and Amazon Linux. I will choose the Amazon Linux one. I will choose on which machine I want to run. Again, there are quite a few options, but we'll go for the GPU ones. So I will take the cheaper option. Again, this will cost me something like $0.50, 60 cents an hour without spot market. So it's not going to be an expensive experience for me. I will quickly go through the wizard. I will open port 22 so I can connect to it. And I'm launching it. Need to provide my key pair. And now the image is launched, being launched. I will go to my console, and I will open a port to allow me to connect to this machine. Again, this is the SSH command. Hopefully the network will work for me, okay. Now I can start a Jupyter Notebook. This is the experience that the scientists are looking for. I will take this secure URL, put it in my machine, and hopefully I will have, okay, I've got a Jupyter Notebook. Again, I will show you how it looks, but this is an example of a nice notebook that I have on this machine. So what is a notebook? Notebook is a place where data scientists can actually do their research. They can write the code. They can read existing notebooks that were shared as tutorials, or maybe some other people in the company created. Again, here I didn't put enough documentation. I did it very quickly. But what this model is doing, it's trying to predict the geolocation of an image. So not an image and give you the labels, just to even tell you where this image was taken, the geolocation of it. So let me, again, there's some code to read. You load the model, you load the images, and so on. So this is an example of an image, and it's coming from the training data, so we know what is the distance, where it actually was given, this is the ground truth. And you can see that the actual distance is about 20 meters when it's on this image, but I can now play with other images. So I was in Tokyo a couple of weeks ago, and this is the Tokyo Tower, and this is the geolocation of Tokyo. This is from my hometown. If you know where it is. So if you don't know, just check those latitude and latitude. This is where I live now. Again, the Space Needle. Another image from Tokyo. Again, this one is a bit silly, but I want to prove you it's actually working on images that I'm taking. So this is my selfie from the Imperial Garden or the Imperial Palace. And if you check the geolocation, it's basically right. So just by what you see in the background, this kind of a building, it knows where it's coming from. So again, this is this kind of a very quick launch in a machine, train a model, load the model from the model zoo, play with that, get the sense of what you can do with this kind of a new technology, again, deep learning and AI. And yes, it's running on the cloud, but you can run it anywhere. The idea is that we really want you to try to come in this kind of innovation and come up with great new ideas around that. Again, I'm running out of time, so we don't have that much time to questions. But again, please keep in touch with us. talk with your account managers, ask questions. We really want you to try and build awesome stuff with that. Thank you.